Okay.
So yeah, because we are talking about decision trees here, let's
Mm.
start with decision trees. We can have some, discussion on decision trees, and then we can proceed further.
Yeah.
So in decision trees, we understood that there is something called entropy, there is something called information gain,
Mm-hmm.
right? And then there is something called gain impurity as well.
Mm.
When it
Mm-hmm.
comes to the industries, you
Mm.
would find that normally we use gain impurities over entropy.
Yes.
Why is it so?
So there is a specifically chart over there. I can explain like this. I have a like this. So if I have a values ranges here 0 to 1. If you talk about the specifically for entropy, entropy values ranges to 0 to 0 to come here 0 to 1 like this. But entropy value Gini index value cannot go beyond 0.5. There because of that, my purity, the split of my purity will be good if we are using a Gini impurity as compared to entropy. The value ranges to 0 to 1. It can be 0.7, 0.8. That means a impurity. But if you talk about Gini index, the value cannot go more than 0.5 because of this only.
Okay. Now, something related to this, let's say if I talk about the complexity as in, let's say, whether Guinea impurity is computationally expensive or your entropy is computationally expensive.
No, didn't get it. Can you come again with the problem statement?
Like with respect to the same question, with respect to
Mm,
comparison between Guinea impurity and your entropy,
mm.
I wanted to understand whether when you use Guinea impurity, you will be getting the results quickly. That means whether it is to be computationally less, expensive, or entropy is computationally less expensive. Which one?
Oh, oh, you're talking about which is expensive, right?
Hmm.
Uh, Guinea impurity or this. That's something I need to think once. Just give me a sec. And
Yeah,
that's something I need to think once. I guess that's something.
I'll give
Uh,
you a hint. You
yeah, yeah,
can
go ahead.
compare the formulas for both entropy formula and
Yeah,
Guinea impurity
formula is,
formula.
yeah, I can see the formula. The formula is it's a no, 1 minus something. So value is different that.
Hmm.
Uh, just thinking. Uh, so I can say entropy. Entropy is better because it ranges to exactly 0 to 1, not 0 to 0.5, I believe.
But
Yeah.
when it comes to the purity of split, we consider the values to be close to zero. Na? Then we say that it is a good split.
Ah, okay, you're talking in that manner. Yes. So you're talking about like which is more expensive, which is not more expensive. Is that what a question,
One
right?
thing we have understood that Guinea impurity is better than your entropy. That is why in
Yes.
the industries also we use Guinea impurity. This is
Correct.
fine. This is
Correct.
okay. But
Correct.
when it
Correct.
comes to the computational efficiency,
Uh, uh.
hmm, with respect to that, I'm asking like Guinea impurity will give you the results quickly or entropy? And for
I
that,
believe
I gave
like
you a
the
hint
formula.
like
I'm
you
just
can.
assuming the formula. So the
Uh-huh.
values goes from the 0 to 0.5 only. So I believe yes, Gini index will be give the better results. Sorry, faster results.
Faster results. Okay, that is
Yeah.
correct. Answer is
Yes.
correct. One more way you can
Mm.
analyze this is when you, for example, the hint that I gave you, when you analyze the formula for both, whether it is entropy or Guinea impurity, you will find that in entropy we use logarithmic terms,
Yes. Correct.
and there are no logarithmic terms in your this Guinea impurity.
Gini index. Yes. Correct.
Mhm.
Correct.
That
Totally
is
get your
why.
point.
So whenever
Yes.
we are
Yes.
computing the logarithmic terms,
Mm.
like
That.
first hand thumb rule that we can have, it would take more time for you to compute a logarithmic term.
Correct.
So that
Correct.
is also
Correct.
another way of, yeah. Okay.
Okay. Good.
So this is fine.
Yeah.
Let's say if I talk about, can we have some discussion on statistics?
Yeah, we can go for that a little bit. Yeah, for sure. We can. But this is something
Okay. Okay.
studies I did a long time back, but yeah, we can try at least. Yeah.
All right. All right. Sure.
Yeah.
So in statistics, we study about hypothesis testing.
Mm-hmm.
Yeah. In hypothesis testing, there are different types of tests: Z test, T
Yeah.
test, multiple tests are
Yes.
there. There's
Mm.
something called square test, and all such things are there. So
Yes.
let's say I have a data set which
Mm.
has numeric parameters, obviously, such as
Mm.
age, such as salary. And along with the numeric parameters, I have some categorical parameters as well. For
Okay.
example, you can say gender of the candidate, such as education qualification of the candidate. So these are categorical parameters which we have. Now, if you have a
Mm.
data which looks somewhat like this, or maybe you can have a complete data which is, like right from the beginning till the end, it is completely categorical in nature.
Mm.
So
Mm.
in such a
Mm.
data, what kind of validation test can we apply? Z test, T test, ANOVA, chi-square, which one will work better?
Okay. So that's something I'm just thinking once. Maybe, Z test, T test and all. That's something. Let's give me a sec. So maybe if we talk about, categorical data,
Mm-hmm.
okay, there are some scenarios. If you're taking the Z value, the sample is greater than 50, sorry, greater than 30, we can go for Z
Mm-hmm.
test now. Let me just think. I guess we have to understand the first of the assumptions before that, right? If the assumption, the alpha value is 0.0.5, we have to determine the threshold hypothesis, null hypothesis. And I guess
Mm-hmm.
basis on that, we can decide, right, which test I have to use or not, right? So in that type of a data, these are the scenarios I feel like this is something we have to choose first. Then we can decide which test I have to use, Z test, T test, or F test, whatever test it is. But normally, if I talk about Z test, we have to use if I have a if I have a sample size is that's something I didn't remember exactly. But if the sample size is less than 30, I have to use the
Mm-hmm.
Z test. If the value is greater than sample size is greater than 30, I have to use T test. If I'm not wrong,
I
yes.
think you mentioned other way around.
Okay, okay.
More than 30 will be Z test, less than 30
Oh,
will be
yeah,
T
that's a
test.
vice
Yeah.
versa. That's something, as I mentioned, I just read this long time back.
All right, no problem. So this is okay. Let's say we can have another question, maybe from Python for that matter. Um, in Python, we work on object-oriented programming, and
Yes.
let me give you a use case, and you can help me with how you would be proceeding further. Let's say, imagine a situation that I want to purchase a course. Okay, let's
Mm,
say for that matter, I am a data science aspirant, and I want to purchase a course from any website. Let's say
mm,
Coursera for that matter.
mm,
And when I want to make a payment of 10,000 rupees.
mm,
And when I go for the payment, let's say the interface is that of Razorpay, and Razorpay allows me to pay via UPI, via credit card, via debit card, and you know via
mm,
PayPal. Multiple options are given to me.
mm.
So if you just imagine a situation that I am right now in the what do we say, checkout, we say checkout, no? We are
Yes.
in the checkout page, and it's your Razor Pay checkout page, and I'm supposed to make a payment of 10,000 rupees, and I'm having multiple options such as credit card, debit card, UPI, and stuff like that. So if I want to design this kind of an interface, the UI would look like this. It's fine, but the backend Python programming, if we want to do, so how can we do that using object-oriented programming?
Okay.
A low-level architecture, you can tell me, not very depth.
So low level, you mean to say in simply what exactly the structure is behind it, right?
Yeah, yeah, yeah. Mhm.
Okay, so what I can do, so if you ask me to create a front end, so I can use a Flask, using a Flask.
For front end is fine. Back end for creating the back end.
Okay, so
What can
what I
we do?
can do after that, I can say I can create a Python class for sure, right?
Mhm,
Uh, so I can create a Python code that is related to oops concept.
mhm,
I'll create a class, for example, Razor payment, sorry, Razor pay payment. And what
mhm,
I'll do after that, I'll use a def underscore init initializer self, for example,
mhm,
API key. If we have something, another function, I'll create a order. For example, this is my order summary, amount, which contains the value amount, currency, it's in INR, receipt. These are the input I will be there in the function order. I will create another function that is capture, for example, capture the payment, and that contains a value, order ID, amount, order history. These are the things.
Mm-hmm.
And yeah, this is the class I will build. After that, I will call the class directly. Class, I mean to say, I'll create a, like this, if underscore underscore name under is equal to underscore underscore main, and I will call the my class inside this, Razor payment within that API key or something if I have, and
Mm-hmm.
print the value like this is your payment, this is your receipt of confirmation. Like this is how I will build, right?
Okay. If we go a step in detail of this, and as I mentioned, there are different payment options that we have. For example, you will create a class for payment. That is fine. It will have methods like amount and stuffs that you mentioned. That is fine. Different methods we can have. Now, as I mentioned, payment is one class. That is fine. But there are different types of payment: UPI, credit card. So how can we incorporate them also if I want to?
Okay, you're talking about like I have a different types of payment, and
Mm-hmm.
how do I incorporate this, right?
Mm-hmm.
Okay, that's something I believe, what I will do generally, I'll create a, I'll create another class, for example, I'll create another class like payment, right? No, not,
Mm-hmm.
sorry.
Payment,
For
so we have
example,
created.
yeah, I'll create a, no, no, I have created a Razor payment. This is another
Okay.
class. I will create another class above it that will be payment only, payment, for example. Yeah.
Okay.
And not like this. Yes, sorry, my bad. I'll create another class. That class will be, for example, PayPal payment, for example. Within this
Okay.
PayPal payment, I will call my another class that name is payment only, right? That's inheritance kind of thing, right? That
Correct.
payment
Correct. Correct.
class will consider, uh, order, yeah, create order
Mm-hmm.
something or capture the payment, whatever it is, and I will call that parent class into the
Mm-hmm.
child class. That name is PayPal payment, and within this I
Mm-hmm.
will call a function def capture the payment. I will call all the parameters and I will run this. I believe inheritance kind of stuff. I will do that and it will work.
All right, very nice, very nice. So this is fine. Acha, because we talked about inheritance, what kind of inheritance would it be? Like there are different types of inheritance. What would
You're
we
talking
call
about
them?
like what are different inheritance we have, right? Different
Like
names of
this, and so this specific use case that we are discussing, what kind of inheritance would we call it? Hybrid
okay.
or multi-level, multiple? What kind of inheritance would it be?
Uh, Hybrid inheritance. I believe this will be only that's something I didn't remember. That's something I didn't remember. No.
I think we can keep multi-level.
Multi-level, that's something like in hybrid. No, not hybrid. Multi-level. Yeah, we can consider multi-level. Yeah, because something I'm calling the above it. Yeah, we can consider a multi-level only. Yes.
Okay,
But
okay,
there are
fair
many
enough.
more. But there are multiple
Mm.
ways to, call the inheritance and all. But yes, we can consider that one.
Yeah, because we are talking about just a low level architecture.
Low level
That.
architecture. Yes. Yes.
Mm-hmm. Okay,
Yeah.
so this is fine. Uh, okay, this looks good. With respect to Python, again, let's have a question from Um, okay, maybe we'll discuss that later on. As of now, we can talk about. You are well aware of deep learning, right?
Yes, deep learning I did also long time back, but yeah, I'm aware about. Yeah.
As of now, you are associated with Accenture, if I'm not wrong.
Yes.
So what do you do there? Like, what is your exact day in day out
So
responsibility?
my role is basically I'm working as a sorry, what I can say, data scientist consultant over there. I used to understand the business. There are multiple teammates out there. I have to ask them, oh, this is the problems. I have to explain them because these are the data analyst only. I have to train them. And along with that, understanding the business, I have to generally write down the code because I love to write a code. So 60-70% of the time I spend to write a code and related to Python, machine learning, NLP, deep learning also sometimes, and create the Power BI dashboard and give the presentation to my clients. So these are day-to-day work right now I have the different projects.
Mm-hmm. Okay, okay. So that is fine. Now, like coming back to the discussion that we had to. So
Mhm.
in deep learning, we talk about recurrent neural networks,
Yes. Mm.
and in recurrent neural networks, we talk about you know architectures like LSTMs, transformers, multiple
Yes.
architectures are there,
Mm.
even
Mm.
GRU for that matter.
Mm.
So can you like help me differentiate between your LSTM and transformer? What is the basic difference between these two?
And a stream transformer. So basically, that's something I did. LSTM is nothing but long short-term memory. If I can talk about, both have the good architecture. LSTM has a type of, basically LSTM is a type of RNN architecture only, right? And
Hmm.
transformer is a type of attention based architecture, right? That's something introduced by attention. Yeah, there's something name I forgot that. And if you talk about uh, the difference between them, I can tell you like LSTM and transformers both are effective things, right? In terms of processing the sequential data, but they have a different architecture in terms of capturing the dependencies within the data, right? This is a different way of working they do. LSTM has the RNN connections in between and the memory cells. In RNN,
Hmm.
sorry, in LSTM I'm talking about. In transformers, we have self-attention mechanism of capturing the dependencies without the recurrence. This is the difference between them. And transformers basically, yeah, these are the difference I remember right now.
Okay, nice.
So
Basically,
this
that
something.
self-attention mechanism is what I was looking for. Okay,
Yes, yes.
nice. That is fine. Now, okay, this is okay. Now, let's say, Acha, you mentioned that your day in, day out responsibilities includes, tasks related
Python,
to NLP as well.
Python code, yes. To understand the business, done the Python code, data
Hmm.
cleaning, data manipulation, everything, right? To create the object, create the function, to debug the code multiple times and build the
Hmm.
model, multiple things out there. Sometimes we used to work on cloud services also like AWS and GCP to deploy the
Hmm.
model and multiple things. Yeah.
Okay, so let's say if I'm using, mm, you know, I have a unsupervised data with me.
Mm.
Okay, and let's say, mm, okay, so let's say we have kind of an unsupervised data, and you are supposed to perform data mining on top of it. So will it be possible? Like, have you worked on data mining?
So what you said, like I have a unsupervised data and supposed to perform
Mhm.
a what data mining.
Data mining, yeah, yeah.
Okay, is it possible you're talking about, right?
Hmm.
That's something. Wait, if I have unsupervised data, that means I
Unlabeled
believe it
data.
is possible. Yeah, because unsupervised, you mean to say it's a clustering kind of algorithm I can use to group the
Hmm.
similar data points together. So yes, I believe it is possible to perform the
Hmm.
data mining steps over there because unsupervised machine learning is nothing but it's a good way of discovering the patterns within the unlabeled data. So yes, definitely it is. We can do that.
Okay, okay, fine, fair enough. Let's say if I kind of, you know, come back to statistics for that matter.
Mhm.
Let's say when we are trying to identify correlation between, variables, and when we try to basically, let's say I want to work on dimensionality reduction, and before I drop my features, if I have multiple features in the data, I want to drop few of them. Before I do that, it is a good practice for me to analyze the data, as in, analyze the correlation between them. If the correlation is high, then maybe we can work it out. So
Mhm.
when it comes to correlation, specifically with respect to the variables which we have, there are different types of correlation. There is something called, like, the most important ones are Pearson's correlation, Spearman correlation.
Mm.
So, my question would be, when it comes to, accuracy, or when it comes to, more reliability, which one will be better? Pearson's correlation will give you better results, or Spearman correlation will help you?
Okay, let me think one. Pearson is Pearsman, right?
Yeah, yeah.
Hmm. Let me just think. Let me just think. Basically, if I can talk about, let me just summarize this. Pearson basically check the sorry. Pearson correlation coefficient basically measure the linear relationship between the two continuous variables, right? I can say
Mhm.
if my data is normally distributed, yeah, if my data is normally distributed, uh, just wait, let me summarize it once. Okay, I can explain like this. Pearson and Spearman correlation both provides a good understanding of a data, good information. But in terms of Spearman correlation, maybe give the more good result or robust results in terms of in this particular scenario, I believe, especially when we deal with a non-linear relationship, Spearman will give the good results, what I believe, right? This is something
Okay.
what I
Mhm.
believe.
Okay, okay, fine. So, however, there are other components also, but yes, like in a nutshell, this is not an incorrect statement that you are making.
Yeah.
So
That's
that
maybe
is
this,
fine.
I can elaborate more, but there's something I remember right.
Okay, fine. So that is okay. Let's say if I talk about again, if we come back to unsupervised machine learning, what all algorithms have you worked on?
I can work on clustering and unsupervised. I talked about clustering like k-means, DB scan, hierarchical clustering, and I've used worked upon dimensional reduction. That's come like PCA. Talked about PCA. I talked about long time back autoencoders, and I did something KDE algorithm also. Kernel density
Mm-hmm.
estimation. Yeah, and isolation forest and many more also. But these are the things I've worked upon sometimes. But yeah, whatever one more. That's a priori algorithm I worked upon. Yeah, this is something I did.
Okay, so with respect to your dimensionality reduction, you have worked on PCA. Have you also worked on LDA?
Latent discriminant analysis. I did, but long time back I did.
All right, that means you will be able to recap, no?
Yeah, I can. Yeah, because I have to read it once and it will be summarized because I did it. I did this thing earlier. Yes, that's fine.
Okay, okay. So that is fine. Again, with respect to um, clustering, if I come back, in
Mm.
clustering, we work on, as you mentioned, hierarchical clustering. In
Mm.
hierarchical clustering, we have something called agglomerative hierarchical clustering.
Yes,
So,
algorithm.
so in agglomerative, the kind of visualization that we generate,
Mm.
there is a specific term that we like associate to it, a specific name we give. What is that name?
So to come again in algorithm,
Uh,
when we visualize it, right?
the graph that we get, there is a specific name given to that graph.
Uh, Let me think. I remember this thing. That's something I remember. Wait. That's something I remember. Come on. Dendogram, if I'm not wrong,
Mhm.
right?
Correct, correct.
Yeah,
Then,
dendogram. Yeah, I remember these are the charts out there like this. Yeah.
mm-hmm. Okay. Uh, so that is fine. I think. Okay, so let's say if I just this is the fine. Like my understanding is quite clear. But let's say if I ask you in general, how
Hmm.
comfortable are you in data mining? So how would you rate yourself? Like in a
Out
scale of
of
1 to 10, out of 10,
I
how
can
would you
rate
rate yourself?
myself right now because multiple. It's a long time back I did the steps, but I'm good at. I did data mining multiple times earlier, so right now I can rate myself 8. But if I can summarize each and everything, the concepts, definitely it will be 9 for sure. Then,
Okay, okay.
but based on the understanding of mine right now, I can rate myself 8.
Okay, fair enough. Acha, with respect to cloud, you are as of now working on AWS and GCP, right?
Right now GCP, but yes, two clouds I have worked upon, AWS and GCP. Yes.